So, 2, grasp the trig function. We're starting with the sine function. So the sine function, we're just looking at the basic, y equals the sine of x. So how is this going to look? We're going to fill out this chart here with what the values of this would be. Now notice all these things are going to be in radians. All right, our calculations are going to be in radians when we're graphing these guys. Whenever we look at the graph of it, it's not even necessarily going to have points, as in like 1, 2, 3, 4, 5. It's going to be like pi, 2 pi, 3 pi, and so on. Okay, so sine of x, and we are going to look at it from, we're going to look from 0 to 2 pi. Okay. So now for my x values, I'm just going to break these down into basically what we had on the unit circle. Unit circle, we had what, 6 thirds and halves and quarters, right? Those are pretty much what we did. All right, so I'm going to make this every sixth. Okay. So we'll go from 0, pi over 6, pi over 3, pi over 2, 2/3 pi, 5/6 pi, pi, 7/6 pi, 4/3. We'll go 3/2, 5 pi over 2. That's not right. 4/3, 3 has to be 5/3 pi. Then 11 pi over 6 and 2 pi. All right, we'll talk about how to break these down later, but we're just going to do that. We're going to go every pi over 6. We just kept adding that on. That gets us from 0 to 2 pi. That's what's going to make a full revolution for us here. Okay? Now, a couple options. 1, you can look at the unit circle. 2, you could punch it in a calculator. But every time you find the sine of 0, the sine of pi over 6, you're going to get the same answer. Okay? They're going to be 0, 1/2, root 3 over 2, 1, root 3 over 2, 1/2, 0, negative 1/2, negative root 3 over 2, negative 1, negative root 3 over 2, negative 1/2, and 0. Now, do we notice a pattern there at all? Yeah? I hope there's a pattern. Okay? It's 0, 1/2, root 3 over 2, 1. And then it goes down in that same pattern, right? And then it goes negative in that same pattern, and then back to 0 in that same pattern. So what do you think that maybe makes our graph look like? It would look like a circle if you are going around the unit circle, right? Now we're going to expand beyond. What were you doing there? There you go. Looks like waves. Okay, it's going to look like waves. Each time we go, or when we go around the circle, now we just take it, we stretch it out. Okay. So let's go ahead and graph this guy. So I'm going to graph this. We're just going to go from -1 to 1. That's all the bigger our numbers are, right? Our biggest number is 1, our smallest number is -1. All right, so I have, how many points here? About 12. 1, 2. This is pi. That would be 2 pi. All right. So I put a mark there for every single one of those points that we did above. You all right with that? So like this would be 0, pi over 6, pi over 3, and so on and so forth. Okay. So where would these guys come out at? Well, I like to go with the zeros and ones first. Okay. So at 0, my value is 0. Okay. At pi over 2, it would be 1. So 1 halfway between those other two. Okay? And then back at pi, I'm back at 0 again. I'm at -1 at 3 pi over 2, which would be right here. Then back at 0. Now, as we get forward, those points are going to be all the ones that we're going to need to find whenever we graph these ourselves. Let's just get a little more accurate with this. All right, so 1/2 is, well, we know what 1/2 is. What's root 3 over 2? Somebody punch that in a calculator. Tell me what you get. What's root 3 over 2 at in a calculator? What's root 3 over 2 on a calculator? Okay, so like 0.8, right? 0.9. Okay. All right, so our half is going to be, well, we know halfway between 0 and 1. And our 0.9, 0.8, 0.9 is going to be in between them, these, right? So let's go ahead and point these points on. So the first one is going to be at 1/2 here. So then this guy is a little bit closer to here. Same thing here, back to 1/2. Okay. Down here, 1/2, 3 over 2, 3 over 2, 1/2. That's like constellation, right? Stars. Was that the Little Dipper? Big Dippers? What? You guys laughing at me? Why? I think it's beautiful. All right. Then the last thing, just connect the dots. Okay. Oh, this is really tough to do on the screen. All right. So right there is our sine function. I think it's just beautiful. I mean, it doesn't get much prettier than that in the world of math. Um, what we did there, we graphed a lot of points. Whenever I ask you to graph points, we're only going to do like 5 roughly. Okay, we're not going to do 15. That's just a very super accurate one because I want you to see what the base of it looks like, what the base of sine of x looks like whenever it's in a graphical form. All right, so now let's just talk about this graph a little bit. There's a whole bunch of things I have listed down at the bottom. You guys see that on your notes there? So we're going to go through and we're going to talk about the different characteristics of this. First thing I want to do is look at the overall graph. So I went from 0 to 2 pi, right? That made one full cycle. Or someone said earlier it was a circle. It basically made itself the whole way around, right? Started at 0, up, back to 0, down, back to 0. So this is one full revolution. All right. So we went 2 pi. That would be one cycle. That's also called one period. Okay, so the time it takes, or the distance it takes to go from 0 and make one full revolution is called your period. Okay? So let's kind of look at the stuff below the domain. Remember, your domain is your x or y value. So what is it? X value. Now, this thing goes on forever. We just stopped it here. So my domain would be negative infinity to positive infinity. It's just an infinite function. Okay, what's my range here, though? Range is how far up and down it goes. That's my y values. What's my range? Restriction on here. What's the highest point and the smallest point? 1 and -1. Yeah. My range is -1 to 1. Period, we just talked about it. Period is the amount of time it takes to make one full revolution or one full cycle. What did it take us here? 2 pi. All right. Now, is it an even or an odd function? First off, can you reflect it over the x-axis? That'd be the same? No. You can't reflect it over the y-axis, can you? And the way you can reflect this to make it the same would be around the origin. Okay, it's kind of hard to see here, but this would be an odd function because it would be symmetric about the origin. All right, what is our maximum value? It was 1, correct? Where does that occur at? Where's that? Pi over 2, isn't it? Right here? Pi over 2. Where's my minimum occur at? Which my minimum is -1. And pi occurred at 3 pi over 2. And then my intercepts, so across the x-axis, I have 3 of them, right? 1 and 0. Where else does it occur at? Pi, 2 pi. Now, I want you to notice something here. Each one of these occurred every quarter period. If I would take 2 pi divided by 4, divided into quarters, okay? This would be quarter 1, quarter 2, 3, and 4. Agree with me? Something significant happened every quarter of a period. Okay? So after the end of the first quarter, what did it do? It changed from going up to going down. After the next quarter, it crossed the axis. Next quarter, it went from going down to going up. See what I'm saying here? So that's significant for us, is this quarter period concept. So every quarter period is significant. And we are going to use this fact whenever we get to our graphing our things. That's one of the steps, is finding what a quarter period is. All right, then the last thing I have written on there is amplitude. Talk about the amplitude of this. The amplitude is basically what's the biggest value you have for y here. How high does it go? It's kind of your same as your max. 1. Okay. In this case, it would just be 1. All right, you guys with me on the things we described here? I think the quarter period thing would be a little bit tough. We'll talk more about that in a later example here. But yeah, that's the characteristics of the sine function. That's what it looks like when you graph it. It's just, a beautiful thing of math. All right, so if you want to transform, that was just the base. Okay, remember we talked before about parent functions. Y equals x is a straight line going through 0 with a slope of 1. The x squared, your quadratic, is a parabola through 0, vertex is 0, opening upwards. And then we could adjust it. We could shift it, we could flip it, and all that stuff, right? So let's talk through our different ways that we can shift these functions. It's the same type of concept, all right? So first one, transformation, so vertical shift. If you just add a number onto the end of the function, so y equals the function sine of x plus c. What happens when you add something to the end? Does it shift it up or down? Up. Okay? This shifts up. Okay? If you subtract, what does it do? Takes it down. Nothing changed there. Horizontal shift. Horizontal shift is when you add or subtract something directly to the function, directly to the x. So horizontal shift. If I add something, did I shift it right or left? Left, correct. And if I subtract it, I shift it to the right. Okay, remember, horizontal shift is backwards of what you think it should be. All right, then reflection. We have 2 types of reflections. One, if I make the entire thing negative versus if I just make the x negative. Do we remember this one? This is usually kind of one of those smaller used ones. What's that? Yeah, which way though? Which one's up and down? Which one's left and right? Any guesses? First one is left and right. Okay, so this would be left and right. So it's essentially it's your x-axis reflection. Okay, you reflected about the x-axis. The second one would be your up and down. Shoot, sorry, this is the x-axis. Wait a second, I drew that backwards. Hold on. My fault. My fault. So the first one is about the x-axis. So this would be your up and down. I'm sorry. What? And this is, there you go. Remember, it's opposite, the opposite axis is what shifts it that way. Left and right, you have to look over the y-axis. All right, still good? Okay. Last thing we have to talk about is stretching. We can stretch stuff vertically. We can stretch things horizontally. Okay. So a vertical stretch means you're going to take those waves and just go like this with them. Okay. Horizontal stretches, you would take the waves and you would elongate them. Okay. So a vertical stretch, if I have this, I'm multiplying on the outside. All right. So this might be something like 2 sine of x, where over here it would be sine of 2x. Okay, those are the differences in the two. All right, if you want to write that, you can. But that's the difference in how it would look on a vertical stretch or a horizontal stretch. So a vertical stretch, if the number that you're multiplying by is greater than 1, then you're going to stretch it. If the number is between 0 and 1, which means it's a fraction, all right, then you shrink it. Now, a horizontal stretch, remember horizontal shift is kind of backwards, right? It's going to be the same thing for us here. If I multiply by a whole number, not bigger than 1, then that's going to shrink it. If I multiply by a fraction, then that's going to stretch it. Okay, so just like our shifts, those guys are going to be backwards. All right, now the part I'm sure you're all sitting here chomping at the bit for, right? You guys are excited for this. You want to know how to graph one of those pretty things by yourself. I know you do. Solidmont back here is like twitching out. He is so excited. All right. I mean, Taylor's over there. She just can't contain her excitement. All right. She's just fidgeting like crazy. She's like, man, I want to know. I want to know. She can get home and draw these on her walls. Whenever you guys redo your bedrooms, like repaint them, put like sign functions on the walls. It'd be beautiful. Mallory, your mother would definitely appreciate that. She would. All right. So we're just going to go easy. We're going to graph y equals 1/2 the sine of x. Okay? That's the one we're going to use. So here's the 5-step process for this. 1, you want to identify the amplitude and the period for the function. And most times they're going to say to you in the directions or in the problem, it says graph this function for 0 to 2 pi or something like that. They're going to tell you how far to graph it out. If they don't tell you how far to graph it out, you want to do 1 cycle. Okay? 1 full revolution of it. All right, so you want to identify the amplitude and the period. Secondly, then you want to find the values of x for the 5 key points. So you hear me say it a lot, the 5 key points, kind of like remember when we did like quadratics and polynomials? We had our key points, our x-intercepts, and so on and so forth. This is going to be the same thing here. So our 5 key points, we're going to have 3 intercepts, a max value, and a min value every time in 1 full revolution. So then you want to start with the x value where the cycle begins and add quarter periods to find those values. So I talked about the quarter periods being the important things. That's where things happen. That's how I'm going to find those 5 key points. All right. 3, find the value of y for the 5 key points by evaluating these points. So we can just punch them in a calculator, use a unit circle, whatever we want to do there. And then connect the points with a smooth curve and one complete cycle of the function. Now, again, be careful with this. You're going to have points that's going to look like this, okay? For every single one you do, it's going to look something like this when you go to graph it. This is not a sine or cosine function, okay? And that's why I drew that one with more points on to start with. It has to be a nice smooth line. Okay, more like this. All right, so it has to be a nice curved line. Does not have sharp points. All right, here we go. The moment you all been waiting for. Taylor, you relax now. All right, it's finally here. So we're gonna graph 1/2 sine of x. We'll graph this guy and then we'll stop there for today. Okay. So the first thing, we want to find our amplitude. Our amplitude is going to be the number that's in front of your sine. What's the number in front of the sine? 1/2. So my amplitude is 1/2. Bingo. Ooh, that's an easy one, right? Your period. To find your period, all you have to do is take whatever is with your x value. Is there a number with your x value? No. So it's just 1 times that times 2 pi. So for this case, our period would be 2 pi times 1, which is 2 pi. So it takes 2 pi is 1 revolution for us. Okay, now here's our 5 points. So my 5 points, I need to find a quarter period. What's the size of my period here? 2 pi, okay? So I need to find 2 pi and divide that by 4. Okay, if I divide 2 pi by 4, what do I get? In pies. Pi over 2, there we go. Okay, in pies. Not cherry or apple. All right. So now I start with, do I have a horizontal shift at all? Did I add anything to my x value? No, I did not add anything. It's just a sine of x. So I need to start at 0. That's my first point because there's no horizontal shift. First one is 0. Now I need to add 1/4 to that. So what's 0 plus pi over 2? Pi over 2. All right. What is pi over, now just keep adding until I get to 2 pi. Okay, so pi over 2 plus pi over 2 is going to be, what is it? 2 pi over 2, which is pi. And then pi plus pi over 2 is, there we go, 3 pi over 2. And then lastly, 3 pi over 2 plus pi over 2 is going to be 2 pi. Okay, so there is my 5 key points. Okay, now this is the first one we did, so I'm going to go ahead and evaluate this. I think most of you guys can see, though, that it's going to be what it would look like. I think you'll see after you do a few of them. It's going to start at 0, it's going to go to 1/2, and then back to 0, then to -1/2. All right, but let's just do a chart real quick. If you ever have trouble, make a little chart with these 5 points in them. Okay, so I do a little input-output chart like we did in algebra. My function was y is 1/2. What the heck? Y is 1/2 x, no, not x, 1/2 sine of x. Okay, so I have my 5 points that I just found. 0, pi over 2, pi, 3 pi over 2, and 2 pi. I would plug each one of these guys into my function. So I'd have 1/2 sine of 0, which is going to give me 0. I have 1/2 the sine of pi over 2, which is going to turn out as 1/2. 1/2 the sine of pi is going to be 0. 1/2 sine of 3 pi over 2 is going to be negative 1/2. And then finally 1/2 the sine of 2 pi is going to be 0. And you can punch each one of these in your calculator as long as your calculator is in radians. That's the key though. If it's not in radians, you get some really funky numbers and you're going to go, what the heck's going on, Mr. Thomas? All right. All right. Now here we go. Moment of truth. Take those 5 points, put them on a graph. Okay? This is typically how I draw my graphs for these. Really far off center with the axis because we're really starting at 0 and going to the right. All right, we're not going to have too awful much to the left of 0, at least not right now. As we go forward, some will be shifted left and so on. Okay? So my highest point is 1/2, correct? So I'm going to put 1/2, negative 1/2 on my graph. And then I had 5 key points, right? I got to put those 5 points on my graph. Obviously, the intersection here is going to be 0. All right, so then I need to go 4 more points on there. Okay, it's pi over 2, pi, 3 pi over 2, and 2 pi. All right, so those would be the 5 points I would need. Now, just fill out the points based on the chart I just had. For x is 0, y is 0. Boom, right there. All right, pi over 2 is going to be at 1/2. Pi is 0. 3 pi over 2 is going to be negative 1/2. And then 2 pi be right here. Okay. So then just go ahead and connect your dots with a nice pretty curve. Ooh, that's party. I lied to you. We're going to do one more, or 2 more examples real quick. I lied. We got 10 minutes left. We're good. We're good. Come on, it's our first day back. Our first day back. We gotta pound through this. All right. So, any questions on that graph we just did? Anybody? Now, I want to look at 2 of them real quick. We won't do the entire graph. We won't do the whole entire thing. Okay, I just want to break it down so you can see how the amplitude or the period might change. Okay? All right, so let's look at next one here. Darn. You guys need another piece of paper? Oh, you're good because it doesn't have a back. And only printed one side. Oh, you're good to go. You got lots of space. Okay. We just did, what, 1/2 sine of x. Let's do y equals negative 2 sine of x. Okay. So what's different here? One, I have a bigger number out front now. I also have a negative sign, correct? Okay. All right, so let's just go. We're going to go amplitude, period, 5 points. Okay? We're not going to graph it then. We're going to do that for 2 problems. Take us 3 or 4 minutes. All right, so the amplitude of this guy. And amplitude is whatever the number is in front of the sign. What's the number there? Negative 2. Okay, amplitude we're always going to talk about as a positive number though. Okay, kind of like distance. We can't have negative distance. Can't have negative amplitude, so what's our amplitude going to be? 2. Okay? Period. We're going to take the period, which is 2 pi, divided by the number that's with my x. So what number's with my x? 1. So it's just 2 pi. It would be this number right here. Okay? So my period's 2 pi. Good there. 5 points. Same thing as before, you find the quarter periods. This one here, my quarter period is going to be pi over 2 again, right? I'll write the whole thing out. So I have to take my period, which is 2 pi, divided by 4, which is going to be pi over 2. Okay. Now, last one we evaluated, right? See if we can figure this one out without evaluating it. So here's all my points. I know I have 0, pi over 2. I have pi, 3 pi over 2, and I'm going to have 2 pi. Okay, there's my 5 critical points. Now, based off your knowledge from the last one, we went 0, max or min, 0, max or min, 0. Correct? I think it'd be a pretty good estimate there that first, middle, and last are all going to be 0. Yeah, these guys would all be 0. Now, the only thing different is that negative sign up top, right? So in the last one, we started at 0 and went up. What do you think that negative sign makes us do? We go down first. Okay? So our negative is going to be in this one. Now, amplitude is 2. That means our highest point is going to be 2, right? So my minimum point would be what? Negative 2. Perfect. And then this will be my max point then. What's my max point going to be? Positive 2. Good. Okay, almost done. Last one. What happens if I multiply the x by a number? Okay, so let's look at y equals 3 sine of 2x. Messes up just a little bit, but not horrible here. No. All right, amplitude number in front of the trig function. What is it? 3. Amplitude's 3. Bingo. Period. Okay, period. Take 2 pi divided by the number with your x. What number's with your x here? 2. So what's my period? Pi. Perfect. Okay. My 5 points. 5 points, I take the period, and I divide it by 4. So it's just going to be pi over 4, right? Now, if I add these up and find those 5 points, I go every quarter period, I should finish at pi, right? So my 5 points, I'm going to have 0, pi over 4, pi over 2, 3 pi over 4, and pi. It would be 2 pi over 4, which is 1/2. 2 quarters is 1/2. Okay? Now again, there's nothing crazy going on here. Feels pretty straightforward. So first, middle, and last should all be what? 0. 0, 0, 0. Okay. Now, is it positive or negative? Positive function. So did we go up or down first? We went up first. So my second point would be my max, which is going to be what? 3. Fourth point is going to be my negative max, which is going to be negative 3. Perfect. Questions? Okay, you have 1, 2, 3, 4, 5, 6 problems for homework. Pretty nice, isn't it?